Go ahead, sir.
Hi everyone, this is Prakash and introducing Jaimit Wasawa of UOTF. He has been volunteering and contributing to the uh, ML, that is machine learning, AI/ML study circle, in which he has taken a number of use cases. Now, this will be one of the last case use cases related to uh, similar listing on vacation rental platforms like uh, you do for your vacation travel. And so I would hand over to Jamid to do the ML system design for this specific use case and go over. And at the end of the call, we will be taking question and answer. It will almost be an hour or so. So thank you. Jamid, take over and go over the presentation. Thank you.
So, hello everyone. My name is Jamit Asa, and we have been together with Prakasa and UTF. We have been presenting different use cases for AIML study circle. So, this time's use case is vacation rentals, similar listings on vacation rental platforms like Airbnb and stuff. So we'll go over them. And more than the whole system discussion, this is more of a feature discussion and how the feature works. So we'll be discussing about how the feature works and how it recommends the similar listings on the platform. So let's get started. And we'll also be following the same framework that we have been following. So when we say similar listings, you can see a screenshot of Airbnb where we have selected Airbnb. You can see on the top left, Airbnb, then you entered Arab Emirates, then Dubai region and Dubai. So already there is a listing that has been selected. And with respect to that listing, other 9 listings has been suggested by the platform. So this is the feature that we have been will be discussing this time. So the similar listing feature. So there are 9 similar listings to the one that has been selected. So let's get started with how it works. So clarifying the requirements. So to design a vacation rentals similar listing feature where business objective BO is to increase the number of bookings. And of course, we will be discussing this uh, system with many constraints and assumptions. So let's go through them. So when we say similar listings, meaning they are in same neighborhood, city, price range, etc., then the model will only utilize a user's browsing history during the training. Then a listing for logged in users and anonymous users will be same. So we are not going to differentiate the logged in users and anonymous users for the time. Then we are assuming that there are 5 million listings on the platform where new listings will appear one day after. So during this gap of one day, the interaction data of the new listing will be gathered before it is being posted live. Then for the training dataset of the model, we only have a user listing interaction only. So we will not be using the user attributes of age and location or listings attributes of price or location. And also the, yeah. So moving further, just a second. So framing the problem as an ML task, which is what we do when we have to translate the business objective that we have mentioned of increasing the number of bookings into the ML objective, or in translating the business objective into ML tasks. So defining the ML objective is to accurately predict which listing the user will click next, given the listing the user is currently viewing. And also, whenever a user is viewing some items, there are some similar characteristics to the next item that user usually browses through. So this is what we are trying to discuss. So You can see in the diagram there is a current listing that is being viewed by the user. The similar listing system will recommend with respect to the current listing which is being viewed another similar listings. So choosing the right ML category for which model shall we go for, which ML category shall we go for. So first we have traditional recommendation system, and there are session based recommendation system. So going to the traditional recommendation system, we so most recommendation system works on understanding users long term interest or users generic interest. So it is based on users historical data. And however, there is a different approach here, which is when to use users' long-term interest. So social media and other such platforms uses long-term generic interest for accurate recommendations for friendships or connections, then similar photos and videos to view with the one that is being selected. So you can see similar snapshot of YouTube's homepage. So yeah, and there are different videos being recommended starting from EOTF's own video, and there are based on the past interaction of the user on the platform. The videos are being recommended to the user, and it takes into account a long past historical data. So, but and there is also a session-based recommendation system uh, where where a different approach lies for use cases such as buying furniture, pre-owned or uh, pre-owned or new, or vacation rentals, where the time frame whose recent context is of more importance. So you can see that the screenshot of Amazon. So and there is a blender being selected. So in compared to that blender, other such recommendations have been made. So these are the kind of items, or these are the kind of searches that the users do not have it every day of their lives or monthly or so. So these kind of recommendations takes more recent actions of the users into account rather than having long past historical data on the platform. So a blender being selected and another similar blenders being displayed to the user for the choice. So this is what Airbnb or e-commerce like Amazon or travel booking platforms rely more on short-term interest to make recommendations. So Airbnb bookings on location and e-commerce for similar products. So a typical browsing session of a user might look like this, and that he might go for t-shirt, uh, then shoes, then pants, then bags, then a smartwatch, and what else would uh, user user search for next. So these are very random, and so that is the reason in the short uh, historical or more recent historical data is needed. So this is a 2D embedding space. So you can see there are different classes, and each of those classes have some of the similarities or in which class they would lie. So you can see there are living creatures. So man, woman, king, queen. And those are the attributes of a more human related. And then there is a dog. So within the class also you can see the a dog has been placed far from the human attributes, but still in the class of the living creatures. So, and this is the way how embedding space uses are is used, and for a representation of similar embeddings. So, embeddings of simply put it, they are the representation of uh, words or different objects in numerical form. So, so choosing the session-based recommendations as our as a choice for the ML category. So it's a widely used technique to build a session-based recommendation system to learn the item embeddings and their co-occurrences in a user's browsing history. So session-based recommendation system aims to predict the next item given a sequence of recent items browsed by the user, and users' interests are context dependent and evolve fast. So a good recommendation heavily depends on the user's most recent interaction and not the generic interest. So this is the way the embeddings are used and that are created by platforms for different uses. So Instagram uses account embeddings for explore feature for recommending different kind of content in the explore feature to depending on the user's activity on the platform. Similar for Airbnb for listing embeddings for a similar listing feature as we have seen in the first slide. Then we have a word to vec, which is a process in natural language processing for creating meaningful word embeddings. And you can see in the diagram that there is a listing that is being viewed as LT by the user. And similar to the listing that is being viewed, there are three other listings that are found or are being displayed. So this is the way we are going to use the embedding space for representation and for the similarity of the listing with different other listings. So moving further with the data preparation, in data engineering, we have user data, listing data, user listing interaction data. So, th- so this is what the user data looks like. This is normally the kind of social media platforms collects the user data for. Then and there is a listing data. So and there are two examples of the what listing data might look like from ID, host ID, price, square feet, etc. Then on the season, the low season, different prices on the seasonality of it. Then next we have a user listing interaction data, the data that we are going to use for the prediction of a similar listing. So you can see user ID and listing ID being interacted, and what was their interaction type. There is a click, and there is a booking interaction type. Then the source, how they found the uh, listing. So one was from search feature, and the other was from similar listing feature, and the timestamp when they happened. So moving further with in data preparation for feature engineering, so user search history will be used, and browsing sessions are search sessions. So search sessions are a sequence of clicked listing IDs eventually getting booked without any interruption. So you can see in the image that a user started to look for listings from L1 and the time it spent eventually to L20 where the user eventually booked the listing. So for that, we will be extracting search session from interaction data. So this is what the extraction look like. So we have session ID, click listing IDs, and eventually booked listing IDs. So for moving to model development, for model selection, so we'll be using a neural network because a neural network is the standard method for learning embeddings. Then uh, depending on complexity of task and amount of training data, we can choose a different neural network architectures, and there are also hyperparameters. So one way to choose hyperparameters associated with neural networks, neural network architecture are number of neuron layers, activation functions, etc. And we can experiment and choose the best architecture that works for us. So for our for our case, we'll choose a shallow neural network architecture for learning embeddings. So now we have chosen the model, but so we are going to train the model, and how we will be training, that will be discussed. So for training the model, initializing to listing embeddings to random vectors, eventually learning through search sessions, the embeddings using sliding window method. So, so training the model starts by initializing the listing embeddings to random vectors, then later gradually learning through search sessions using sliding window method. As the window slides, the embedding of the central listing, the embedding of the current listing that is being viewed by the user is updated to be similar to the embedding of other listings that are in the window. And those listings will be deemed as similar, and will be dissimilar windows to the listings which are outside the window. So model uses these embeddings to predict the context of the given listings. And of course, we'll train the model daily to adapt to the new data meaning new listings been added. So constructing the data set for training the model. So we'll use a negative sampling, commonly used, which is a commonly used learning embedding technique. So negative sampling aims at maximizing the similarity of words in the same context and minimizing it when they occur in different contexts. So, but instead of minimizing all the words in dictionary, except the context words, it randomly selects a handful of words depending on training size and uses them to optimize the objective. So, so we'll be forming different pairs. Positive and negative using search sessions. So positive pairs are similar embeddings and negative pairs are dissimilar embeddings. Positive pairs are a central embedding and a positive listing, and negative pair is a listing and a negative listing. So central listing and positive pair will be having the label of 1, and central listing and negative pair will be having the label of 0. So as the window slides, in the sliding method, the central and context listing will be forming the positive pair, and uh, positive pair will be will be created using the central and the context listing, and also the central and randomly sampled listing will be used for forming the negative pairs. So this is what's happening in the diagram below, that we have uh, L3 as the central listing, and in L3, L4, and L5 as the central listing. And with respect to those, positive pairs have been formed. And with respect to those, the negative randomly sampled listing, the negative pairs are also been formed. So moving further for model development, choosing the loss function. So loss function basically measures the quality of the output predicted by the model and the ground truth value. So the steps to compute the loss function is you can see in the diagram that there are two listings. The model creates their embeddings, and using the dot product, we find the similarity. And using a sigmoid function to treat the value as probability, and cross entropy function used to measure the loss between the ground truth value and the probability predicted by the model. So so this is the formula of the loss function that we'll be using. So there are different terms, and there are terms of C for a central listing, P for positive listing, and for negative listing. Now DP is the pair of a positive listing. DN is the pair of negative listing. EC, EP, EN are the embeddings for central positive and negative listings. So the first term calculates the loss for positive pairs, and the second term calculates the loss for negative pairs. Now, even though the loss function is a good starting point, but there is some improvement that we need from this loss function. There are the improvements that we need are for a positive pair are not optimal for helping users to find the eventually booked listing. So the positive pair are is only calculating what will be the next click by the user rather than what will be the booked listing for the user. And the negative pair are not working well for the same regions. So as you remember, the negative pair was randomly sampled uh, to create the negative pair. So a negative listing was randomly sampled for creating the negative pair, but negative pairs for the same region did not work uh, or wasn't working efficiently for this. So to address these two issues, we'll be adding something as something called using the book listing as a global context. So So during training, the window slides and some listings will fall in and out of the context, while eventually book listing will always remain in context and used for updating the central listing. So, so if I go back to the loss function, so the first for the positive pair, the during the training, the embeddings of the central listing is pushed closer to the embedding in the context and not towards the embedding that is eventually being booked, which results in embeddings that is good at predicting what user will click next, but not what a user eventually booked, which is not the optimal path for helping our users discover a listing that leads to a booking. Now, for the second thing, the negative pair are sampled randomly for different regions. So instead of different regions, we need negative samples for the same region also. So, however, the user search within a certain area, this may lead to embeddings not working well for a same region listings. So, instead of negative pairs of a different region, we need a negative pairs for the same region. So, so this is what we need for the improvement in the loss function, and this is what we are going to address it for the positive pairs. So, using the global context as a book listing, so it will be always there in pair with a central listing and eventually book listing. So, this will be pushing in the embedding space more towards the embeddings of the similar listings. So and this is the improved uh, a loss function, and the first two function and the first two terms of the loss function are the same functions, whereas the third and the fourth terms are the improved ones, where C C is for central listing, D is for the book listing, and the pair belongs to the D D book the or the pair or D booked shows us the pair of central and the book listing. And similarly, for D hard is a pair of central listing and the hard negative listing of the same region. So as those two terms are added, which will be calculating the shortcomings that we had with the original loss function. So to address the issues, we added these two terms. Now, going to the evaluation of the offline metric, the so for evaluation, we use offline metrics to compare the output quality of the model to newly developed ones. So the one way to do it is to test how good the models are at predicting the eventually booked listing based on the latest user click. So in order to measure that, we'll use a metric called the average rank of the eventually booked listing. So this is what has been shown in the image also, that the user started with L0 as the first clicked listing, then eventually went through uh, went through all the listings till L6, where the user eventually booked the listing on L6. So the train model has to recommend the listing L6, which is booked higher up in the listings. So the listing that was given by the train model is, you can see the row down below, where the L6 has been listed on the second position. So so this is the way we'll compute the value for the average rank of the eventually booked listing across all the sessions in a validation dataset to compute the value of the metric of or the offline metric. Now moving on to the online metric. So so as you remember, the business objective BO was to increase the number of bookings. So for that, we will be using click-through rate, which is a number of listings divided by the number of recommended listings. But click-through rate only measures the engagement, but it does not measure how many listings were clicked and then converted into this booked listing. So for that, we'll use a session book rate, which and the formula is a number of sessions turned into booking divided by the total number of sessions. So as the value of a session book rate increases, and the more revenue the platform will be generating. So this is the whole overview of the whole feature that we have discussed. So starting with the training pipeline, we have which is responsible for adapting the new data of listings and the user interaction data. Then we have indexing pipeline, where all the embeddings using a trained model can be pre-computed and stored in the indexed table, which significantly speeds up the prediction pipeline. So indexing pipeline is responsible for maintaining and indexing the index table, and if a newly trained model is available, the pipeline recomputes all the embeddings using new model and updates the index table. Then next we have a prediction pipeline. So you can see the currently viewed listing by the user. So prediction pipeline is responsible for recommending similar listings to the current listing being viewed. So there are different components to the prediction pipeline. So first is a embedding fetcher service, which is responsible for fetching embeddings during training and acts on whether it finds the embedding or not. So if it finds the embedding, then during training the vector has already been learned and is available in the indexing table, and it fetches directly from the index table. But uh, if it doesn't find during training, it uses a heuristic uh, to handle new listings. So to create an embedding for a new listing, it finds three geographically closed listings that do have embeddings and of same price range and type. So when enough interaction data is gathered about the embedding, it is learned by fine-tuning the model. Next, we have nearest neighbor service. So as you remember, we assumed that we have 5 million listings on the platform. So computing similarities of all the listings will take time and will slow down the serving process. So we'll use the approximate nearest neighbor service to speed up the search process. Then we have a re-ranking service. which modifies the list by applying filters used by the user. So let's say there is a price filter being used. So the listing, so all the listings that are above the price mentioned by the user, those will be removed. Similarly, the listings of the cities other than currently being viewed can be removed from the listing before being displayed to the user. So after applying all these kind of logics, uh, we uh, we get the final list of recommendations by the platform based on the currently being viewed by the user. So to summarize the whole feature that we have discussed, we started with clarifying the requirements, where we mentioned the business objective, which was to increase the number of bookings. Then we uh, we translated the business objective into ML objective and ML task. So the ML task was to predict the user clicks. Then we discussed about the specifying input and output. The input was the listing currently being viewed by the user, and output being the similar listings to the one being viewed. Then we discussed about the ML category, in which we discussed about the traditional recommendation system and the session-based recommendation system. And we went for a session-based recommendation system. Then data preparation. So data we discussed for data preparation in data engineering. We discussed user user data, listing data, and user listing interaction data that we use for predicting the similar listing. So further, we in feature engineering we discussed about the search session, and based on search session we moved further. So then we in model development we discussed about neural networks, and we went for a shallow neural network. Then we talked about negative sampling, adding global context to the training, and adding same region negative pairs to the training data. So these two are the shortcomings or the improvements that we needed for our loss function. So these were the improvements. Then we evaluated the model that we created. So for offline metrics, we used average rank of eventually booked listing, and online metrics we used CTR in combination with session book rate. Then for serving, we discussed the training pipeline, indexing pipeline, and prediction pipeline. And in prediction pipeline, we discussed the embedding fetcher service, nearest neighbor service, the re-ranking service. So even though the whole feature has been discussed, it has been discussed within assumptions and constraints. So, but still there can be other improvements regarding the feature alone, or in the system as well. So, so the improvements can be what is a positional bias and how to address it. So positional bias is basically if you go for, if you, let's say you are surfing through Netflix, the first search in the Netflix is something to be considered as the only correct search. So this is what a positional bias means, and how to address the positional bias. So these are the kind of topics that can be used to improve the feature further. Then how does a session-based approach compare to random walk? A random walk to random walk with restart can be used to recommend similar listings. Then how to use users long-term interest in session personalization for session-based recommendation system. So as we discussed, giving the recommendations, but how can we leverage the users long-term interest and or generic interest on the platform to make more uh, personalized recommendations to the user. Then in the end, we have how to incorporate the seasonality into our similar listing system. So during the year, the habits or the human behavior are not same for purchasing or having a vacation or whatnot. So how can we incorporate the different seasons being experienced and into the listing system, and how can we improve uh, those listings based on the seasonality to it. So thanks a lot for listening. This was my presentation for similar listings on the vacation rental platform. Thanks a
Thank
lot.
you. Thank you. Thank you, Jamie, for the short, sweet ending to a long 10 weeks of hard work. This use case obviously is related to how do you um, improve the search listings which are obtained for vacationing and all. So if you go vacationing and you use some uh, portal, it gives you some options. So how to improve that? And so there are many platform, as you know. Uh, the only thing is the conditions may differ from location to location, season to season, as you mentioned in there. That is interesting. Like if it is Diwali season in India, or if it is what you call Christmas season in Europe, or it is some Thanksgiving in US. Depending on the season, the vacation rental availability is usually tight, and obviously you are trying to get the best for the people. And it was interesting. This does provide the various portings here for the different use cases for ML systems you did. And I think I have, maybe I should ask Nikhil, who is on the line. If you have any questions, please go ahead, because we have almost finished this series, and we would like to begin a new series on this, which could be something different, like could be asset tracking, could be something else. It could be Gen AI. So we are looking at options. So go ahead, whatever your question on this image processing, which we have done several times, which will be useful for you. And what do you see in this? Would you like to present something? Go ahead.
Yes. So, yeah, I liked today's session, and because it was more less, although it was packed with theory, it was more that we can relate to, uh, in our daily lives. Because
Correct.
yeah, it is one part, like as a human, you will obviously vacation, and you will need to do the bookings, and that is when recommendation systems would come in, to book your air tickets or to book an Airbnb or a hotel or whatever it is. So yeah, I actually had that one thing which was actually covered up in the very last part. I was more concerned about, because I was here through the entire talk, and I thought that this thing about the seasonality was really missing. And yeah, I mean, so Jaimit got that in the very end. It was in my mind throughout, like from around to 6:15. I was about thinking there should be something to handle the seasonality of visiting places, and that is a really a big factor. And I think we could also have something in that direction also. So that was my input. I mean, uh, that is really something that we need to answer very soon.
Jamie, go ahead. Your answer to him.
Actually, I didn't catch it, the question. What was it? The seasonality related.
Yes, yes.
Diwali.
How
So
can we do it?
Example, if it is Diwali season, what happens? How does the listing change? Or go ahead. Maybe Nikhil, you explain. Probably
yeah, right.
he
So
better.
whenever, like, there in tourism there are always seasons. Of maybe if it's summer, so you'll go to Goa. If it's winter, you'll go to Kashmir. So
Yes.
so they are like more seasonal. Or say if there's Ganpati, people will come to Mumbai. Or say if it's Holi, people would go more to say
Rajasthan.
Rajasthan, or this Vrindavan, or Delhi. So we need to address that, and to
Yeah.
address that also we need to take care of the calendars of various calendars, say like Indian calendars, uh, Gregorian calendar that is like by default, but again, say Chinese calendars or even calendars that are followed by some other, maybe some big uh, you know, a big area in some remote part of Africa would be following a different calendar, and that would be something that people would like to visit to. So we need to have something that collaborates with various type of calendars, including the natural phenomenon of seasons.
Yeah. So, one way to incorporate seasonality to it would be two ways can be location based, completely have it location based, and where what are the peak time when when certain locations see high rise in the tourism, and other way can be as you mentioned about the calendar, that with respect to Canada, we decide that the platform itself will be recommending more towards the area
Right, right.
where we find the peak tourism during the certain time of the year and stuff.
Yes.
So
Excellent. So,
so a different kind of data have to be gathered, and more actually the scope that was discussed was only the interaction data for the recommendation. But as more recommendation or more data should be incorporated in order to this feature more and more accurately for recommending the listings.
Right, and I think we were focusing more on the say uh, mm, the behavior of the user, right? So it might
Yes,
be from the cookies, say,
yes,
or maybe embeddings in the URL
yes,
string, right, in the headers.
yes.
Okay, right. Yeah, so yeah, I think having that would also help, and this was mainly for like specific service vendor, you could say.
Yes.
Okay, okay, yeah. All right, and I think that we usually have this occurring in our daily lives whenever we try to search for a holiday place. We always
Yeah,
get
because,
a lot
yeah.
of recommendations. Yeah, that's it.
S-
so good. I think we have reached the end of the session today, and this recording will be available. And then we also have other recordings, around dozens of them, I believe, in the Open Tech Foundation or emerging Open Tech. I think Open Tech Forum under uh, 1140. I think it is at 1140 or something is there. It's in the YouTube. We have shared with everybody. So I think we will close this session as of today. The AIML circle for the use cases.
Yes.
We will possibly another 1 week we'll deliberate over various things what we want to do. I think Nikhil, I will also work with you to find out what kind of proposals we can make along with Jamie. We can
Yeah, yeah.
look at the practical usage now. There is how do
Yes.
we implement example railway asset system if you want to really track how
Hmm.
what is the design, because we
Yeah.
have learned the various techniques of design, but where do we apply what, how do we apply, that is what we do. So I think I will end the recording here with this. Yeah, go ahead, stop the recording and then we can close the session,
Yeah.
uh, and then we can meet again sometimes in the coming week to go over.
Yeah. Sure. Sure.
Sure.